So now we'll see a problem for symmetrical components. To understand the concept of symmetrical component, write down this is problem 4 for module 3. A balanced 3-phase 4-wire supply is connected to a 3-phase star connected balanced load. Balanced load drawing 60 amp current. They are given two different cases for this. If fuses in the Y and B phases are removed. Case 1, before the removal of fuse, ma'am class la irukku ma'am கூப்பிடுறோம் உங்களுக்கு. After the removal of fuse, find the symmetrical components of live current. So the diagram is given like this. So here they are telling there is a fuse connected at y position X. Here there is a fuse, and B phase also there is a fuse. Okay, there is a fuse at Y and there is a fuse at B, and all these three phases balanced in load. There is a balanced in load. All three phases are balanced. When it will be unbalanced? When this fuse are removed. When the fuse is on, there is a flow of 60 amp current in Y bus, 60 amp current in B bus, and phase Y phase and B phase, and then R phase also 60 amp will be there. If Y and B are removed, Y and B fuses are removed, then the current is disconnected in Y phase and then B phase. At the time the system is not balanced, it is unbalanced, it went to unbalanced. So you need to find out the symmetrical component. Symmetrical component means three symmetrical components we are having. One is zero sequential, positive sequential, and negative sequential. All this sequential current you need to find out. Live current value they have given, not live, the actual current, balanced or imbalanced current they have given during balanced time. During balanced time, all three phases are having 60 amp current, flowing 60 amp current. After removal of fuse, only R phase is having 60 amp, Y phase is 0, B phase is 0. So now you understand the system, I mean understand the problem, right? Any doubt in question? Any doubt in question? Can we go for solution?
Just a minute, sir. I'm copying the question.
Okay. This diagram in question they will not give. That is the three-phase diagram. Only theory will be given. So you need to understand that there are three-phase current, I mean three-phase network, and that two star-connected network having what fuses at Y bus and Y phase and B phase, and find out the symmetrical component current before removal of fuse and after removal of fuse. And current value they are given 60 amp. Done? Can we go for solution? Students, am I audible? Can we go for solution?
Yes, sir.
Okay. Yes, ma'am. Yes, please. Any doubt? Okay. So we'll go for a solution. So the given current is 60 amp. So what will be my IR value? IR is equal to tell me. That is case 1. Case 1 IR is equal to 60 amp and angle is 0 because I am taking R as reference. So if I take R as a reference, then 60 angle 0 because it will be starting angle for me. You can take any reference, no problem. And amp. Then IY is equal to how much? Case 1 means before removal of fuse. So Y also having current. Before removal of fuse, Y also having current, right? So how much it is? 60 angle, how much angle? 60 angle minus 120 can I put? Or 60 angle plus 240 I can put. 240 degree, both are same. Similarly for IB, 60 angle minus 240 I can put, or 60 angle 120 I can put. Both are same. So this is the current, actual current flowing flowing in the circuit. But this is balanced. Why we are going for symmetrical components is mainly we are focusing for unsymmetrical or unbalanced system can be represented with three balanced sequence or three balanced phasors. That is why we are going. But in this question, they are checking us whether you have understand the concept or not. So this is a balanced network already. For this balanced network or balanced phasor, they want to find out the sequential current. What we understand is, note, please take a note for balanced phasor, okay, that zero sequence and negative sequence value must be equal to 0, then only it is balanced. Only positive sequence will have some value. Only positive sequence. All about I'm speaking about current. All about I'm speaking current. The current at zero sequence and negative sequence must be 0, then only it is balanced. And positive sequence will have equal to whatever the value you are having in actual, equal to actual value. So this is how it should be happen for the balanced system. And for unbalanced phasor, the current I will have some value at zero sequence, negative sequence, as well as positive sequence also. It will have equal to some value. Some value it will have for unbalanced system. I am all about speaking is symmetrical component. Symmetrical component will have some value. Symmetrical component is nothing but 0, negative and positive. This is also symmetrical component. So we can represent by this current value, we can represent the unbalanced value. That is why we are going. So by this theory or by this understanding, what will be your zero sequential value for case 1? Someone tell me. This is the case 1. For this, zero sequential must be what? Some value it should come, or it is not, it must be 0. And for a negative sequence, and for positive sequence, some value should be there. That we are going to find out. Okay, again, when fuse are not removed, the supply is balanced. So that's theory I already explained. Now, first we will go for one by one. Okay, we'll go for we also know that to find out the zeroth sequence, first we will go for zeroth sequence to find. Why? Because why 0 and then positive negative you are going, you can go anywhere, but they are asking symmetrical component. Symmetrical components includes positive, negative, and then 0. All these three values we need to find out, then only it is symmetrical component. So first we will start case 1. For case 1, we will find out 0 sequence first. Sequence for case 1. We know that already, we have clear understand that it must be 0. Let me check. Must be 0, we will need to check. And we know IR0 is equal to IY0 equal to IB0. Why? Because in zeroth sequence, all the angle between other phasors are 0. So only magnitudes are there. So whatever the magnitude we are having, and it is balanced. We know that it is a balanced. Why balanced? Because of the theory, the unbalanced phasor can be represented by 3 balanced phasors. So obviously the R0 is also one of the 3 balanced. So obviously it is a balanced, means it should have a equal magnitude also, and angle is 0 for zeroth sequence. So IR0 is equal to IY0 and then IB0. So I will take any one value from this. So I will take, if I find out IR0, it will be equal to IY0 and also IB0 also. So we also know the matrix. Which matrix? Can I write you?
Sir?
What is the matrix? IR0.
Sir, are you taking not in what we had today?
Sorry.
Are you taking a Joseph's class also?
Yes, my.
Till 10?
Yes, I have asked. Sorry for not informed to you. I asked a permission with Joshua sir also. Thanks for him.
Thank you, sir.
Please, Sagar, put a message that Joshua sir's class all students must join you. I already asked permission with Joshua sir.
Okay, sir.
Okay. So also we know that matrix. I will write a small because I don't have space from this matrix. IR2 is equal to one third. Sorry, I put okay. I will write here 1 1 1 1 alpha square alpha 1 divided by 3 into IR IY and then IB. IR IB only. So one third we need to multiply in this. Please remember that. So if that is the case, then we'll first go for IR0. So IR0 is equal to this one third of IR plus one third of IY plus one third of IB. So I will take one third outside and then IR value IR plus IY plus IB. Correct or not? From the matrix. So now tell me what is the value? IR is equal to how much? IR0 find out. 1 divided by 3. What is the IR value? Given in the question. 60 angle 0 plus IY 60 angle 240 plus what ma 60 angle 120. Correct or not? Any doubt up to this? Because I took value of IY value is here. I took value of IB value is here as given in the question. Okay, so what will be my IR0? IR0 is equal to, yeah, tell me. Tell me what value it will come. What is alpha here? What is alpha? One angle. Anyone please tell me one angle 120. Correct or not? What is alpha value? The first itself we have taken. Alpha is equal to one angle 120. So here I will write 1 divided by 3 60 0 angle plus here 60 alpha square plus 60 alpha 60 alpha. Can I move to next page? Please write down. Can I move next page? Okay, so now IR0 is equal to 1 divided by 30. So I will take 60 outside in the common. So because here also 60 is there, 60 is there, 60 is there. So inside it will be 1 plus alpha square plus alpha. Now let me check one small value here. Say for example, if this is the three phase and this is alpha square. So this one that is this one plus alpha this alpha plus okay 1 plus alpha and then plus alpha square 1 plus alpha square. Okay, so this is alpha square and it will start at it will end up at starting position, that is 0. This is 0 alpha and alpha plus. If I add this 0 plus alpha square, again it will come to 0 position. Correct. So this entire part is 0. If this entire part is 0, then my IR0 is also 0. So what is the conclusion here? IR0 is equal to 0 means for balanced for for balanced value my IR0 is equal to 0, that also equal to 0, that is because of equality IY0 is also 0 and IB0 is also 0. So for the balanced phasor, the zeroth sequence values are 0. This is proven. This statement is proven. Clear? So here take it as a formula itself. So wherever you are seeing 1 plus alpha square plus alpha, if you are adding these three things, straight away put is equal to 0. Because hereafter also we will see such values. 1 plus alpha square plus alpha, you will get such values. Okay, so this zeroth sequence for balanced system is 0, we have proven. What is next? 0 is done. Can we go for negative sequence now? I'll take new page. So to find out negative sequence component. So first I will start with R2 itself, because I'm taking this as a reference as R. So I will go for IR2. IR2 represents what? Negative sequence. Am I right? IR2 is negative sequence. Correct or not? So again formula from the matrix, that is nothing but IR0, IR1, IR2 is equal to 1/3 of, so please memorize this, 1 1 1 1 1 alpha alpha square into alpha whole divided by IR IR IY IB. Okay, so this is the formula. So we need to find out negative sequence IR2. So negative sequence IR2 is this one. So if we need to find out IR2 is equal to 1/3 of IR. So just multiply this with this, IR plus alpha square into IY plus alpha into IB. Alpha into IB. So what is the value of alpha? Alpha square. IR2 is equal to 1 divided by 3. What is IR value, man? This is for case 1. This is also for case 1 only. So case 1, what is IR value? Please tell me someone. Yeah, please fast. What is IR value? No one is responding. Why no one is responding, ma? Please tell me someone. What is IR value? 60 angle 0, right? Plus what is alpha value? Alpha square value? 1 angle 240. Alpha square is 1 angle 240 into IY value. What is IY value? 60 angle 240. 60 angle 240. Okay. So plus alpha value is 1 angle 120 into IB value is 60 angle 120. 60 angle 120. Okay. Now solve this. IR2 is equal to 1 divided by 30. So let it be 60 inside. Later in next step we will remove outside. 60 plus. So this is 60 angle 240 plus 240 480 plus 60 120 120 is 240. Correct? So if we know that 480 minus 360 is how much? How much, ma? 480 into 360. So 120 can I put? So
Yes, sir.
IR2 is equal to 1 divided by 30. So 60 I am taking outside. Then I will get 1 plus. Okay. So okay, let it be 60 inside. Next step we will go. So 60 into 120 plus 60 angle 240. So IR2 is equal to 100 by 30. Next 60 angle 0 plus 60 into alpha, correct? Plus 60 into alpha square. So IR2 is equal to 1 divided by 3 into 60, 1 plus alpha square. So what will be my value? IR2 is what? What will be my IR2? Do you remember 1 plus alpha square is? Are you listening? Students, please tell me. 1 plus alpha square is 0.
Zero.
So IR2 is also 0. So what is the conclusion? For the balanced system, negative sequence is also 0. Correct or not? IR2 is equal to 0. Now I need to find out for IY2, and then I need to find out for IB2. Correct. These are also what phases in negative sequence. So we also know that what is IY2 formula or IY2 value? IY2 value is alpha IR2, correct? IY2 is alpha IR2, and IB2 is IB2. Where is IB2? IB2 is here. So IB2 is alpha square IR2. Alpha square IR2. Alpha square IR2. So we know IR2 value is 0. So obviously IY2 alpha into 0 equal to 0. So IY2 is also 0, and alpha B2 is equal to, sorry, IB2 is equal to alpha square into 0. So IB2 is also 0. So in negative sequence also all three phases are having 0 value. We concluded. Correct? Correct or not? So what next for case 1? So for case 1, what we need to do next?
So for the zero sequence, also all the three values are zero, right?
Because see here, for 0 sequence, IR0 is equal to IY0 is equal to IP0. So obviously if I find out IR0, then obviously this is also 0, this is also 0, correct?
Yes, sir. Yes, sir.
I have already said that. So similarly, we need to find out for third sequence. What is third sequence for case 1?
Positive.
Positive. Very good. So to find positive sequence of case 1. So from the matrix, tell me which is positive sequence here. This is negative, we done. This is 0, we done. So what is remaining part? IR1, correct? So IR1 is equal to one third of, tell me the value from the matrix. IR plus alpha Y1 plus alpha square IB. IR plus alpha IY plus alpha square IY. This is capital letter I. This is alpha square IB. Correct? Am I right? Yes. Alpha square IB. Okay. Now apply the value and find out the value. IR1 is equal to one third of 60 we know, plus alpha is nothing but angle 120. There is one angle 120 plus Iy value is for case 1 60 to 40. 60, that is, sorry, multiply, this is multiply 60 to 40 plus 1 angle 240 into 60 120, correct? Yeah, solve this. IR1 is equal to 1 divided by 3, 60 angle 0, sorry, angle 0 plus 60 360 plus 60 360. Okay, so this is also 0. 360 is nothing but 0 only. I have only 1/3 of 60 angle 0 plus 60 angle 0 plus 60 angle 0. So 1/3 of 60 angle 0 is 60 angle 0, right? If you add all this 60 and divided by 3, you will get 60 only. So IR1 is equal to 60 angle 0. What is the conclusion? What is the conclusion you got? For balanced system, I will get some value of I plus 1 in the positive sequence. One more observation, anyone please tell me here, one more observation is there. This value is equal to what? This value is equal to question value itself. What is IR1 in the question? It is 60 angle 0. Same value we are getting for the positive sequence. That means what? If your unbalanced system can be represented by 3 balanced system, and if unbalanced system by chance it is balanced, then your negative and 0 will be getting cancelled, and all the current flowing in the actual circuit will be flowed in positive sequence. So this is equal to actual IR, main IR. IR1 is positive and IR is same. So this is one observation. Next, for the same positive sequence, if you want to find out for IY1 and then IB1. So tell me the formula. Tell me the value of IY1 with respect to R. IY1 with respect to R is this one, right? Alpha square IR1. Alpha square IR1. For IB1, where is IB1? This is IB1. So the value is alpha IR1. This is alpha IR1. So IY1 is equal to 1 angle 240 into 60 angle 0. So IY1 is equal to 60 angle 240. Any doubt here? How this got any doubt? Similarly, IB1 is equal to 1 angle 120 into 60 angle 0. So this is IB1 is equal to 60 angle 120. Okay, let's check what is the question value. So IY question itself, or the total current for the balanced system or unbalanced system of the given system, is 60 angle 240. Here also it is 60 angle 240. For IB1 it is 60 angle 120. Here also it is 60 angle 120. So we prove that all the current flowing when without fuse, with fuse, that is before removal of the fuse, all the current are flowing in the network is equal to positive sequential current. First case is over. We have solved case 1. What is next? What is next? Can we go for case 2? Okay. Yes, case 2 will go. What is case 2, ma? After removal of fuse, how the system or symmetrical components, how the values are presented, we are going to see now. Okay. So case 2. after the removal of fuses. Why fuses? Because in Y bus and Y phase as well as B phase, both fuses they are removed. If both values are removed, only I will get IR phase will have the same current, that is the value given in the thing, same current is flowing. What about IY? IY is equal to IB is equal to, because I removed the fuse, so there is no any current, so can I mark it as 0? So this is the given value for us now. So this is the given, because fuse at Y phase and B phase are removed, so there is no flow of current in these two phases, so it is 0. Okay, so for case 2 we'll find out zeroth sequence. To find zeroth sequence for case 2. Okay, so we know that IR0 is equal to IY0 is equal to IB0. So if I find out only this value, I'll get the thing. So for the reference, I will not write the matrix. I hope you are written in your notes, so you are directly going to tell me the matrix formula. So what is the formula for IR0? IR0 is equal to 1/3 of same IR plus IY plus IB. So IR0 is equal to 1/3 of this is how much? 60 angle 0 plus 0 plus 0. So I'll write here, I'll start here. R0 is equal to 1/3 of 60 angle 0, that is nothing but IR0 is equal to 20 angle 0 ampere. So we know that IR0 is equal to IY0 is equal to IB0. This is the question some of the students asked just now. It is all these three values are 20 angle 0. Now what is the conclusion? We know that the system is unbalanced. Now for the unbalanced system, for the zero sequential current, I am getting 20. For the unbalanced system, I am getting zero sequential value. Okay, next what? To find what? Can we go for positive or negative? Okay, we'll go for positive. We'll go for a positive now. Positive sequence for case 2. Okay, tell me what is IR2 or IR1 for positive? IR2 or 1? Please tell me someone fast. For positive sequence, IR2 or IR1? No answer.
IR1.
Very good. So it is IR1. IR1 from the matrix I will get 1/3 divided by IR plus alpha into IY plus alpha square into IB. So we know that this is 0, this is 0. Only IR is there. So IR1 is equal to 1 divided by 3. IR value is nothing but 60 angle 0, and again this is 20 angle 0. IR1 is also 20 angle 0. Then what next? IY1 is equal to, and then IB1 is equal to, tell me IY1 and IB2. IY1 can I write alpha square into IR1? This is alpha into IR1, correct? And alpha square is nothing but 1 angle 240. This is 240 into IR1 is nothing but 20 angle 0, and this value is nothing but how much? 20 angle 240, correct? So IY1 is nothing but the value is 20 angle 240. Similarly for IB1 is equal to alpha is 1 angle 120 plus 20 angle 0. So IB1 is equal to 20 angle 120. So this is my IB1. So this is the value for what? For positive sequential for case 2. What is next? So we got zero sequential, we got positive sequential, and what is next? Can we go for negative sequence?
Yes, sir.
Okay, so for negative sequence for case 1, sorry, case 2, yeah, tell me, this is IR1 or IR2? Yeah, please tell me, for negative sequence. IR2, right? So from the matrix 1 by 3 IR plus alpha square into IY plus alpha IB, not beta, this is B. We know that this is 0 and this is 0. So IR2 is equal to 1 divided by 3 into 60 angle 0. So IR2 is equal to 20 angle 0. So similarly we need to find out for IY2 is equal to, and then IB2 is equal to. So IY2 is equal to, as per the simplification, alpha IR2, IB2 is equal to alpha square IR2. So IY2 is equal to 1 angle 120 into 20 angle 0. So this is IY2 is equal to 20 angle 120. So this is the value. And IB2 is equal to 1 angle 240 into 20 angle 0. And then IB2 is equal to 20 angle 240. So we got the value for all. Now, so this is the question they have asked. So for extra knowledge, what I will do, let me check what is I1 value, IY, and let me check what is IB from the values we got from this sequential. As per the formula in the beginning, I have said that we know IR is, this is the formula, IY is, this is the formula. By just applying this formula, whether you are getting these values or not, let me check. Okay, so IY is equal to IY0 plus IY1 plus IY2. That is for case 2 I am telling. Don't get confused, for case 2 after removal. So what is the value of IY0? IY0 is, here we find out, 20 angle 0. IY1 is 20 angle 240. And then IY2 is 20 angle 120. So 20 angle 0 plus 20 angle 240 plus 20 angle 120. So how much you are getting? So how much you are getting? 0. Why? Because if I take 20 outside, it is 1 plus alpha square plus alpha. So we are getting 0. IY is 0. What is IB? Very good. So IB similarly, IY0, sorry, IB0. IB0 plus IB1 plus IB2. So IB0 is 20 angle 0 plus IB1 is 20 angle 120 plus 20 angle 240. So this is again 20 if I take outside 1 plus alpha square. So I'll get 0. So IB also 0. Clearly we got 0 for IY and IB. Okay. So if I find out for IR is equal to, what is the value? IR0 plus IR1 plus IR2. So what is the value? Tell me. IR0 20 and then IR1 20. So 20, here also it is 20. And IR2 is also 20. So it is 20 angle 0 plus 20 angle 0 plus 20 angle 0. So how much? 60 angle 0 we are getting for IR. So what it's mean? During for case 2, if I remove Y phase and then B phase, if I remove the fuse, only at R phase I am getting 60 angle 0. That is the total current in the actual circuit. So we verified that also, but you know, don't want to verify this step in the examination. Up to this it is okay. Just for your verification I just solved this. Okay, any doubt up to this? Any doubt? Okay, that's all about this problem. That is nothing but sequential component theory and then problem we have seen today.